Okay, hi everyone. My name is Carol Ko. I am a statistician at DLH. At DLH, we do statistical analysis of toxicological studies conducted by our clients. And today I wanted to show you a dashboard we built to look at microtiter plate data. This work was done in collaboration with my DLH statisticians, Catherine Allen Moyer, Sean Harris, Guan Hua and also our collaborators from NIHS, Helen Cunny and Keith Shockley. So before I jump into the dashboard, I just wanted to kind of give a quick overview of what a microtiter plate is. So microtiter plates are a standard tool in laboratory experiments. These are plates that contain wells arranged on a grid. And each well can handle small volume of liquids. So scientists like to use these a lot because they can run several experiments at the same time. And so the idea here is that each one of this well is considered to be an experimental unit. So you can put different test articles and different concentrations across these wells. These plates come in different sizes. This is a picture of a smaller one. In my example, I'm going to be using a 384 well plate. So it has 16 rows and 24 columns. So once all of these wells are filled, these plates go into a plate reader where a device can measure responses from each one of these wells in the plate. So in my experience working with the scientists, they usually run these plates run these experiments using several plates to account for the different factors that they're interested in. And so examples of these factors might be the type of assay, cell culture, or the number of test articles that they want to experiment on. And usually when I get the data from these experiments, I get them all at the same time. So typically I'm dealing with several thousand rows from dozens of plates. And so ideally, I usually like to be able to visualize each plate and check for any potential data issues before I do any statistical modeling. But you know that it can be very difficult to see and understand what's happening when you have too much data. So my team and I, we've thought about how can we make the visualization process easier. And a solution we came up with, and that was also thankfully also easy to implement in JMP, was a dashboard made up of a local data filter and then 3 graph builder panels so that you can kind of like look at different views of the same data set, but like a different, from different perspectives. In this presentation, I'm actually not going to show you how to build a dashboard. Instead, I'm just going to refer you to a link, a tutorial in here that's linked in here. And yeah, so right now I'm actually going to switch over to JMP so that we can look at this dashboard in more detail. So while I'm switching over, I just wanted to say that all the data that I'm using here have been simulated. All of the chemical names or initials that you see, they're all fictional, just for the purposes of this presentation. So the one key thing to kind of do if you're working with plate data is to make sure that you understand the plate design. Because with these types of experiments, it's really they're prone to have any, they're prone to have edge effects or like location effects. And so understanding what chemical was placed in which well actually can give you a lot more insight in your data. So because of that, I added a graph builder tab. It's kind of tucked away in here that shows you the plate design or the plate map. And I'm gonna maximize this so that we can see this in more detail. There we go. Yeah, so this is an example of a plate design. And some key things to look for are, you know, what type of controls do you have and how many do you have? So in this particular example, I have vehicle controls labeled here as media. and they look to be, they're located in the first two and last two columns of the plate. I also have a negative control on the first row, and then two different types of positive controls, A and B, in rows L and M. And the colors correspond to the different concentrations. So we're going from darker to lighter green. And so that means we're going from highest concentrations to lower concentrations. And each one of these initials, you can think of them as like a specific chemical or a test article. And so it looks like each row has a particular test article. And the other thing to note with this particular example is that it looks like we have duplicate wells. And so you can see like pairing. So for every two wells, the same concentration and test article was used. So yeah, so if you want to go back to the dashboard, just click on this restore button, and then it'll bring you back to the dashboard. So when you're just handed like a batch of data and you don't really know much about it yet, one thing that I like to do is I just kind of toggle back and forth between, so this is assuming they're from the same assay and two separate plates. So I just kind of toggle back and forth to see, did they actually use the same plate design? It would make sense that they did, but that they do, but sometimes you never know. So this tells me that yes, the plate design is the same, but the data, of course, is changing because they're run at different times. And then also you can toggle back and forth between your different assays. And here I can kind of see, okay, the layout, there's some similarity in terms of where the vehicle controls are located, like these yellow columns. But it looks like in this other assay, there is a negative control. Now it's in row B. And then there's no positive controls, and they also use a completely different set of chemicals. Okay, so I'll switch over to this other tab where I have another heat map, but this time when I'm plotting, the colors correspond to the values of my responses. And this, how I've had them laid out, it's basically similar to as if you're looking at the plate. And this can be very useful, again, because of those edge effects that tend to happen in these types of experiments. So what I really like about the dashboard is that it's very easy to isolate problematic observations. So from looking at them at these different views. So for example, when you look at this heat map, the first thing that I see are like this column striping effect that's happening. And so what you could do is you could select these wells. And what I'm doing is I'm just holding my shift key while I'm kind of like selecting these. And what you'll see is that in these other panels, they start to kind of highlight too, because of all like interconnectedness between these different graphs. And so what is actually happening is that these darker wells, these are the points that are kind of like above. So it looks like something kind of went wrong in here. So I would typically, what I would do is I probably go back to the scientist or the person who did the actual experiment and ask, oh, was there something that what happened in here? And what can we do about, do we need to exclude them? Do we now need to like take the average of like these two duplicate wells in order to analyze our data further? The scatter plot here on the right kind of shows you like a distribution of your data points. This can be useful if there is some natural chemical groupings in your plate. And so for this particular example, because I knew that I had 3 different types of controls, so it's just kind of easy or like useful for me to kind of look at them. How are they distributed when I group them according to like chemical groupings? And what stands out to me when I look at my vehicle controls is that I have a cluster of observations right here that seem to be lower than the others. And so again, when I highlight them, immediately see, oh, these are the observations that are coming from the last column, like in this corner. And again, this is going to be another one of those, like, when you talk to the scientists who did this experiment, you can kind of ask them, did something happen in here, or maybe do we need to like exclude these observations if they're not, if they're just an artifact of something else. Another way that we've kind of used this dashboard, aside from like, showing our clients, okay, this is what your data looks like, is also like a way for them to be able to tag or flag observations that they want us to exclude in our analysis. So an example might be, okay, so maybe they go through like the dose response curves here on the bottom, and there's this one particular data point in here that looks really suspicious because it's like higher than the rest. Maybe they looked at it and then they decided, okay, maybe we should just exclude this observation because it's not, there's something kind of weird or funky that happened in here that's not reflective of what they're expecting. And so what we would ask them to do is to highlight, this observation. And then if you right click on that particular point, go under rows, and just do a row label. It doesn't look like it did too much in here. It just added the name because I have name as a label in my data table. But what it does is that if you go back, if you look at your data table, and this is that row that we just added a label to, now it has this yellow tag on it. And you can also, and then you can create, so imagine if you have a lot of these observations that you're tagging, and maybe at the end of it, you want to have a listing of, okay, these are the observations that you want to go back to and look at in more detail, or maybe these are the observations that we need to exclude in the analysis later on. What you could do is you could create a column by using some row state formula. They're kind of like hidden right in here. So I just did label row state. And what this formula does is it turns these labels into a 0-1 indicator. So any row that has a label will have a value of 1 and then 0 otherwise. Yeah, so I guess one more cool thing that I like to point out, because it's actually hard to find, but ever since I found this, I keep using it. It's actually in the legend panel of, so an example of this is in this heat map. If you right click on the legend color key and under gradient, it actually opens up a lot more options for customization. So the two that I really am thankful that JMP has this is the scale type and the range type. So scale type, the default is linear. So you could see that the values of my color key kind of goes up in equal spacing. You could change this to a quantile cutoff. And actually, if you set that, it totally brings you a very different perspective of your data. So I need you to be careful or be more thoughtful about what it is that you want to show, but that is an option that you can use. So in this view, you could see that the last row maybe looks a little bit weird too. The fact that it's all yellows, and anything that is on the edge of a plate, I'm always worried about them. So that's another question that you can ask the scientists. Let me go back to it again. And so I'll switch it back to linear, but there's actually a lot more options in here that you can play around with. The range type as well, I like to use. So the default option in JMP, I think what JMP does is it rounds up or down your min and max. And so we end up with like numbers that look nice. But if it's important to you to see the range, the exact range of your data, you could switch that easily in here. And now you know that the maximum value you have is 115 and the minimum value is minus 84. I'll just switch it back to default. And then lastly, there's some aesthetic options in here. They're all pretty straightforward. I do like using discrete colors, especially when you have a continuous gradient. And that's because, so this is what it looks like continuous. And then I'll switch back to the discrete. For some reason, my brain just reads this a lot easier than when it's like continuous. I like to use that a lot too. And then so finally, I just wanted to say that even though this may seem like a really simple idea, we're just putting together, you know, like graph builder panels, it actually ended up to be a really effective and useful tool in revealing insights into the data that we would have missed otherwise. So make sure like that you play around with dashboards and yeah, I hope you learned something useful in my presentation and thanks for your time.